All right, here we go. If you guys could get your review assignments out in front of you there. Light slip. Did you get light slip? Go get light slip. All right. So chapter 3 review. Now, number 1, I'm not going to do all these for you. We're going to do some of these together. I'm going to pause and explain. If you have questions, please ask now because you have a test tomorrow, right? All right, so let's see how this goes. So surface area is, okay, which one is it? Is it A, the amount of matter contained in a three-dimensional object inside? B, the area covering just the surfaces of a three-dimensional object? C, the amount of space occupied by a three-dimensional object? Or D, the area covered by a two-dimensional object? Remember, two-dimensional object would be like a square. Why is this disappearing? A three-dimensional object is like a cube. Okay? Okay, which one is it? A, B, C, or D? What do you think?
Really answer
B. B. All right, the area covering the surfaces of a three-dimensional object. When it says surface area, that is talking about a three-dimensional object. It is the area covering a three-dimensional object all the way around. Yes. Now, the amount of matter inside, volume is the amount of space it takes up, capacity is how much it can hold. So that's definitely both volume. And then this one is like just the area of a two-dimensional object. We wouldn't call that surface area. Question? Okay. All right, so that one is B. All right. All right, I'm going to, like I say, I'm just going to do some questions with you, and I'll get you to do the rest. But let's take a look at number 2. A regular decagon is a shape with 10 sides of identical length. A piece of chimney pipe has open ends shaped like a decagon, decagon bases with sides that are 4.5 inches. The prism is 16 inches tall. What area of aluminum is needed to construct this piece of chimney? Okay, so there's a lot of information in this question, so you got to break it down. Okay. Okay, so 10 equal sides. Now this might be tough to draw, right? You don't have to draw it perfectly, but let's just see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, not very good, but you get the picture. We don't have to draw it perfectly. I'll try and fix it a little bit here. Let's see, let's bring this in a little bit. And do that. Okay, close enough. Beautiful. Yeah, perfect. So these angles are all wrong, but crisp. 10 spots, yeah. Okay, so 4.5 inches is the length of each side, right? Now, it is true that there are going to be little triangles that form this, right? There should be 10. And if I drew this correctly, there would be 10 equal triangles. You get the idea? 1, 2, 3, 4, 5. Okay, 6, 7, 8, 9, 10. The prism, now when it says the prism is 60 inches tall, we're talking about a chimney pipe. So a prism has the same area of base on the bottom and top, and it's three-dimensional. So if you kind of look at this, I'm going to draw the sides. I'm going to go down this way. Okay, you see? So it'd be like a prism like this. And this is 16 inches. Okay? So what is it says what's the area of aluminum that's needed to construct this piece of chimney? Well, the chimney is like a hollow tube or a hollow thing. So there is no bottom or top, I guess. Right? There's no bottom or top. So we don't have to calculate the area of this bottom. We don't need to worry about that. All we need to worry about is the sides. So each of these sides has an area of 16 times 4.5. And there's going to be 10 of them. Okay, so it's just the outside part. So the surface area we're looking for, oops, I'll do it over here, is 16 times 4.5, right? Times 10. So what number is that? What number do you get there?
720.
720, everyone agree with that? Yeah, everyone agree with that? Check that on your calculators, make sure we have agreement there. So 16 times 10 is 160 times 4.5. That's 720. I think that looks about right. Okay. So number 2 is A. All right. So what three-dimensional shape would number 3 create? This is a net diagram, isn't it? So what is the name for this one? What's your guess for 3? Sorry? A triangular prism? Okay, so this triangle would be one end. This would be another end. This would be the base. And then these two would be the sides that kind of fold up, right? So you guys in agreement? Triangular prism? Good, I like it. So here's your triangle. And that's what it should look like right there. Awesome. So D. Okay, let me know if you have any questions, guys, because I'm just going to kind of keep going until you stop me. All right, surface area. I'm not going to do this one. You're going to do this one on your own, but it might be helpful to draw a net diagram. And again, the net diagram would be just like what we saw in the previous question. Okay, so a triangle for an end, then the bottom, triangle for the other end, and then each side. And you have to add up the areas of all of these sides, so the 4 different areas. The 2 ends will be the same, and these 2 sides should be the same for sure. Anyways, I will let you work on number 4 on your own, but that's how you do it. Okay, let's take a look at number 5 together. The surface area of the lateral face. Okay, so the lateral face of this cylinder, remember lateral means side. So we're literally talking about the surface area of the wraparound part, right? So not the ends, we're not considering the ends. We can think about it as being hollow. It maybe isn't, but we don't care about what that area is. So remember, if we were to cut this down the middle and cut it around the top and let it fold out, this would be a rectangle, right? The lateral surface area. The height would be 118. And what would be the representation of this top part here? Anybody remember how to? Sorry? Okay, yeah. This top part right here is the circumference of this circle on the top, right? So what's the formula for circumference? Anybody remember that? Okay, there's 2 ways you could say it. 2 pi r, 2 times pi times the radius, or the other one is pi times d, right? Diameter is 2 times r. So we're given the radius, so let's use the first one. So this is 2 times pi times 38.
It's 238.76.
This is right here?
Yeah, the circumference is 238.76.
238.76. Okay, everybody else get that too? Okay, we'll do a quick check on that. Okay. Where's yours? Do you have yours? Where is yours?
I don't even know. That's in the board.
Yeah, who did you?
So thank you.
Yep. All right, so I'll let you guys finish up that. So obviously this area is going to be the height times this circumference, okay? All right, maybe you even have that done already. Okay, surface area of the cylinder. So that means we have to take the area of the top and the bottom, which is going to be 2 times, what's the formula for the area of a circle?
2 pi radius?
Times radius squared. That's right. Okay, so 2 pi r squared would be the top circle and the bottom circle, or the top and the bottom. And the wraparound part, well, we just mentioned what that was. That was for, oh, sorry, we're going to add to that. We're going to add 2 pi times r times the height. 2 pi r times height. That's the lateral surface area part. So the 2 circles on the top and bottom, and the lateral surface area part. So surface area 2 times, now please use your pi button on your calculator. If you're not going to use your pi button, you have to use at least these 5 decimal places, okay, to make it accurate. But use the pi button on your calculator to make it really accurate. And then this is 5.2, and just the 5.2 is squared. Plus 2 times pi, so 3.14159, times r, which is 5.2, times h, which is 10.6. I would suggest, doing this first, or even just these 2 first, and then times 5.2 squared, whatever. But do this first, and then do this one second. Do it in pieces so you don't make a mistake. If you try and plug that all into your calculator at once, if you make one little mistake without a bracket or something, it could be a wrong answer. So just be careful there. And I'll give you a chance to do this one and let me know what you guys get for an answer, and we'll double check it. Okay, so finish that up. B or D? B? All right, B should be your answer, yeah. Should get something like 516.226. 5. So rounded 516. That's correct.
Well, what did you get for 5?
What did you get for 5? I didn't give you the answer to 5 yet. Maybe I'll give you the answer later. I'm not giving you the answers for all of them.
I thought we were just like checking our answers. No?
You're checking your answers with the answers I give you,
Oh
yeah.
wait, you didn't give us the answer for 5.
That's correct.
Okay.
Yeah. Yeah.
Sorry.
No, some of this, I'm not giving you all of the answers. This is partly I'm doing your assignment with you, but there's some questions that you...
At the end? Will we go through our answers?
No. You're going to have to finish some of these on your own. Yeah.
I mean, like to...
All right. The surface area of a sphere. What is the formula for the surface area of a sphere? Who remembers that? Or who has that written down on your cue card that you have ready for your exam tomorrow?
4 pi r squared.
4, okay, I hear 4 over 3, and then I hear 4 pi.
4 over 3 is the volume.
So one of them is volume, and one of them is surface area. That's right. So surface area for a sphere is going to be what? 4 pi r squared. That's right. Okay. So the radius is 5.5. So 4 times pi. Yeah, a sphere is the ball, right?
Yeah.
Yeah.
I thought you said... I don't know, I'm tripping. I thought you said...
The ball, yeah, sphere. And then r is 5.5, so 5.5 squared. Okay. All right, I'll leave that one for you guys too. I mean, I did most of it with you, but you'll have to finish that on your own. Number 8, surface area for a cone. Surface area for a cone. Now, if we're gonna add the bottom 2, we know that the bottom is a circle, I guess, right? So that's pi r squared. Who remembers or who has written down what the formula for this lateral part is? Yes.
Pi times r times s.
Pi times r times s. That's exactly right. Good job. Now, what is s in this diagram?
The side.
The slant height.
Yeah, it's the slant height or the side length here kind of thing. So it's 20, right? That's what s is. And then this is r. Very good. Now, do I need the height? I don't really need the height in this formula, do I? So if you're given the height, let's say you're given the height and you're not given the slant height, you might have to use Pythagoras, right? To find out what S is, right? So there'll be some questions like that coming up. But this one's pretty straightforward. So pi times 12 squared plus pi times 12 times 20. And you should get one of those answers when you do that. So what I might do is I might I'll let you know, but I might give some more answers at the end of the video, and then you guys can watch the video at home and find out what answers are correct. Okay? But yeah, some of this is for you guys to do. Okay. The volume of the box. Boy, this is super easy, isn't it? Right? Can someone tell me how to do this to find the volume of the box? Exactly. Length times width times height. You just multiply those three numbers together. Make sure that they're in the same units, right? This is centimeters, centimeters, and centimeters, so that's important. But yeah, just multiply those together, okay? That's number 9. All right, 10. Let's take a look at 10. What is the volume of an aluminum can? So aluminum can is in what shape there?
Cylinder.
Cylinder is correct. So a cylinder. Now, how do you draw a cylinder? Draw like an oval, like a flattened circle a little bit. And then draw 2 lines down, same length. And then to connect those 2 lines, make a circle that's just the same kind of curvature as this bottom side of the top circle. Okay, so cylinder, yeah. So it's a height of 8 and a radius of half that width there is 1.5. Okay. Can hardly see that, but. All right, so what's the volume of a cylinder?
Pi r squared times height.
That's right. A cylinder is a circular prism. A cylinder is a circular prism, right? So it's the area of the base times the height. That's all it is. So it's pi r squared is the area of the base times the height. So you're doing pi times 1.5 squared, that's the radius squared, times the height of 8. And those are all in the same units, so that's good. You can just use those exact numbers. Okay, so do that on your calculator. All right, so let's take a look now at, 11's a good one. Let's take a look at 11. So 11 says, how many 500 cubic centimeter bags of sugar will fit inside a packing crate measuring 1.2 meters by 1.1 meters by 0.5 meters. Okay, so some of you have been asking me during like quizzes and even tests sometimes, like how many centimeters in a meter, stuff like that. You guys need to know that, okay? Those basic conversions, write that on your cue sheet, study that up, okay? So make sure you know that. But notice that this is in centimeters cubed and these are all in meters. So probably what you should do here, this is a crate, so it's got 3 dimensions, so it's kind of like a box, right? So how do you draw a box? Well, start with your square or rectangle in the front. Okay, start with that first. Then I would suggest going from each of these corners, drawing an angled line about the same slant, and then connect the end of those lines. And again, mine isn't a very neat drawing there, but that's roughly how you can draw a box, right? Okay, so 1.2 meters. Now, I'm going to change the meters into centimeters because we have to have same units. So, I'm not going to write anything more down now. We're just going to talk it out. So, 1.2 meters is how many centimeters? What do you have to multiply that by? You have to multiply by, there's 100 centimeters in a meter, right? So if I multiply 1.2 times 100, what do I get? Right. So the bottom part here would be 120 centimeters. So you want to write that down. What's the side value here? 1.1 meters. How many centimeters is that? 110. Because you multiply this by 100. That means you move the decimal place over twice. So 1.1, if you move it over twice, that becomes now 110. So this is 110. What about this one? How many centimeters is this one? 50. Very good. Move that decimal place over 2 times 50. Okay. So what we need to do is find the volume of that box by multiplying those three numbers together. Then we'll get a total volume. Now that total volume isn't going to be the answer. Do you guys have a question?
No, we figured it out.
Okay. Just try and keep quiet. I'm just so everybody can hear, okay? Yeah. If you're going to work ahead, that's okay. Just don't talk. So you got a volume for this in centimeters cubed, right? So you got a total volume in centimeters cubed. If you want to know how many bags this size will fit in there, then you take the volume and you divide it by the volume for each bag. So 500 centimeters cubed. And that's your answer right there. Okay? So make your conversions, convert meters to centimeters by multiplying by 100. Find the volume of the box by multiplying all three numbers together. And then do that total volume divided by the volume per bag, and you will get how many bags will fit in there.
I got this.
Okay, so I'm not going to go over number 12. I'm going to let you finish number 11. I'm not going to go over number 12. We did one just like that, so it's up to you to do. Okay? Now, this is a good question. Okay? There's a few things that you have to know about a question like this that are very important. Okay? So this is an understanding question. This is not a calculation. You don't just put numbers into a formula and then you're done. You have to think about this. So, what are the dimensions of a cube with a volume of 1,000 millimeters cubed? So there's a few things I want to focus on. Dimensions means what's the length or width or height or radius or whatever, the dimensions. The lengths of the little distances that are important, okay? So in a cube we have 3 dimensions. We have length, we have width, and we have height, right? Those are the 3 dimensions in a cube. A cube, what else is important there is that a cube is a 3-dimensional, it's a box, but all of the side lengths are exactly the same. Like a cube of sugar, the bottom side, the side here, the distant side, all of those sides are the exact same length. So it's 6 tiny squares. Or this dimension and this dimension and this dimension will all be the exact same. Okay? So 1,000. Okay? 1,000. What number times itself 3 times equals 1,000? That's the question. So is it 2? 2 times 2 times 2, does that equal 1,000? No. Is it 20? What's 20 times 20 times 20? Is that 1,000? No, that's like 8,000, right? So that's no good. So what number is it? And you can see them here. Notice, it can't be this one because those numbers are all different and a cube has all the same size. And it can't be this one. So is it the 10 times itself 3 times, or is it 10 cubed, or is it 11 cubed? 10 cubed, exactly right. Now, so it's A, right?
Mm-hmm.
Awesome. Now, another way you could find that out is take the cube root. Do you guys know how to do cube root on your calculator? Because the cube root says if you have a cube and you have the volume, you can find out the side length. That's what the cube root actually means. So on your calculator will be quite different than mine, I'm sure.
It only works for cubes, right?
It only works for cube. If it's like a regular box and the dimensions are different, it won't be the same. Okay.
Yeah, I have a cube root.
So you should have something that looks like this, like 3 with a little root sign maybe.
Yeah.
If you have that, then you can use that. That means cube root, and if you type in the 1000 there, you should get 10 as the cube root. So that's the number that's multiplied by itself 3 times. So take a moment, look for your cube root button on your calculator. Okay, let's take a look at 14. I'm not going to do 14 all the way through for you, but let's just examine this question so you can understand a question like this on the test. A rectangular prism, so that is like a box, right? The front face is a rectangle. So it's not a cube. A rectangular prism is probably like a box. It has a square or a rectangle as the faces. The dimensions are L, W, and H, or length, width, and height. Okay. Now, if the width is changed to 2W, so if this width becomes much longer, or it doubles, and the length is changed to 0.5 of the original length, how does the volume change? So this one goes times 2, and this one is half. So this length is really small now, and this length is really big now. So it kind of looks like this, right? Okay. So how do they compare? What you could do is you could actually test some numbers. That might be the easiest. So for option number 1, volume for number 1, let's say you have like 2 times 3 times 4, let's say. Let's just make up any number. So what volume is that going to be? 2 times 3 is 6. 6 times 4 is, what's 6 times 4? 24 is correct. Okay? Now, the second one, where we change things a little bit, I'm going to have, and I'll do it over here, V2 is going to be, what's half of 2? 1. What is 2 times 3? That's going to be 6. And then the 4 that it says stays the same. So what's this one? 1 times 6 times 4 is? 24. So look at that. Volume 1 and volume 2 are the same. So 14, the volume is the same. Well, actually, I'm just going to give you, for 15, I'm just going to give you the start. I'm just going to start it for you. So what is the formula for the volume of a sphere? We kind of talked about this earlier. 4 pi r squared? Close. That's the surface area for a sphere. So what was the other one? 4?
For what?
4 times 3.
Okay, 4 over 3 is the number. And then times pi times radius cubed. Another way you could write that is 4 times pi times r cubed all over 3. That works too. Okay? This might be easier to do in your calculator, actually. So that's probably, either one of those are good, but this might be easier to type in your calculator. So with a radius of 1.4 feet, guess what? 1.4 goes right in here. And then you solve for your volume. Okay, there's the formula. You plug 1.4 into there and should get one of those answers. Number 16. What is the volume of this pyramid? So the volume of a pyramid, you're going to have to know that one too. So look on your papers See if you can find the volume of a pyramid. Again, you'll have to put this on your cue sheet, right? Be in your notes there. So make sure you put that on your cue sheet. What's the volume of a pyramid? Who remembers? Okay. Length times width times height, not slant height, right, at all, but this height, not lateral height, but this height, divided by 3, okay? So that is correct. Watch this. If you had a rectangular prism of the same size, and this point was right in the middle of the top layer. Did you guys see this on a video? Did you watch this on the video? I don't know if I did this demonstration or not, the one you saw, but
I've watched one where they do it like with a cone and with a sphere of the same.
a cone and a cylinder maybe. Yeah. So yeah, so this volume of the pyramid inside this, the rectangular prism has a volume of length times width times height. And the pyramid, because of the shape of the pyramid, because the one base is the exact same, but then it comes to this point in the middle, the pyramid is a smaller volume, and it's always a smaller volume by 1/3. So it's exactly 1/3 of the volume of the larger prism. So that's why the volume of a prism is always length times width times height divided by 3. So whoever said that is perfectly right. It's always 1/3. Okay. So that's going to be, all of these are centimeters, so you don't have to do any conversions. That's good. So you just multiply all 3 of these numbers together and divide by 3, and you should get the volume. So take a moment to do that on your calculator. Let me talk about 17. On an assignment that you guys just had, okay, I noticed this question, you guys had asked me about this question here. So let's talk about the connection between centimeters cubed and liters, okay? Now this is important. 1 liter is 1,000 centimeters cubed, okay? Please make sure you remember that now, because some of you, I think, were a little unaware of that. But 1 liter is 1,000 centimeters cubed, which is the same as 1,000 milliliters. So 1 milliliter and 1 centimeter cubed are the same volume. Okay? So, what amount of ice cream in liters can fit into a waffle cone? You remember what a waffle cone kind of looks like? It's a cone, so it's kind of got a circular top, and then it comes down to a point. It's kind of making me hungry for ice cream actually right now. But this is a waffle cone.
Field trip to Andy's after school.
If you're paying. Yeah. Me too. I'm broke too. Okay. So a cone. Now think about this. The ice cream fills the cone right to the top, but it doesn't go over the edge. So what are we talking about? We're talking about the volume inside a cone, right? Or what is the capacity of this cone? So what's the volume for a cone?
Let's see.
Remember, a cone is like a pyramid. A cone is a circular pyramid. Oh, I think I heard it. What was that?
Pi r squared times height divided by
Exactly. Pi r squared h divided by 3. How this finish for tomorrow? Okay. Now that will give you a volume in centimeters cubed, won't it? Because these are in centimeters. So then what you're going to have to do is take this volume and divide it by 1,000 centimeters cubed to get liters. Okay? So So again, I'm not going to give you the answers, but I'm going to try and lead you through that. So again, find the volume using this formula. That volume will go here, and then you divide it by 1,000 centimeters cubed. That's actually 1,000 centimeters cubed per liter. That's why you have liters as your final unit. Okay?
Wait, did we say which answer we got?
Yes, so you have to select the correct answer, show your work, and select the correct answer there.
Because I got B. Because I got like 0.1.
Okay, guys, 18 is the same type of question. It's just a square-based pyramid. So the area of the square times the height divided by 3 is the area, as the volume there, sorry. Okay? And that's it. 18 is the last question. So there are a few questions that I did not give you the answers to, so you are responsible for doing those ones on your own. Okay? Now, if you check back and watch this video, then at the end of the video, I'll probably give you some more answers. Okay? And that's a good review for your test tomorrow. So, finish that up. All right, so this is due, whenever it's due. For this class this year, I'm making this due tomorrow. At the beginning of the test, it has to be handed in. It's a review assignment, so make sure it's done before that. And I will give you some more answers here. So hopefully you've had a chance to attempt every question. If you haven't had a chance to attempt every question, please pause right now. Finish every question the best you can, and then you can check your answers with this, okay? So you've got, there you go, you've got 1 is B, 2 is A, 3 is D. Let's see, 4 should be B. This one right here. 5, did we do 5? 5 should be D. Right here. Let's see, did we do 6 together to give you the answer for that one? 6 is B. Okay, we did that one together. Now 7, if you finished 7, you should have gotten B for an answer here. The surface area of the cone. Okay, number 8, the surface area of the cone. Finish up your work here. That should be A, 1206. Number 9, the volume of this box. That's easy peasy. This one should be B. Make sure you show your work. Okay, I don't want to see just the answers. You're not getting marks for that. Don't be just copying my answers. I need to show your work. Okay. Number 10. Okay, you finish that off. You should get 57 inches cubed. So that's A. There's a lot of A's and B's here. Number 11. How many of these bags would fit in there? Okay, so there's the process on the right, and you should get for 11. Looks like C. 1,320 C. Number 12, the volume of the cylinder. So the volume of the cylinder, right, is pi r squared h. And number 12, you should end up with letter C here. C for 12. Number 13 we did together, that was A. Number 14 we did together, that was A. Number 15. Okay, so I gave you the formula there. If you did that on your calculator, you should have gotten an answer pretty close to C, 11.5. So C there. What's the volume of this pyramid in 16? There's the formula, and you should have gotten something close to 24,700 cubic centimeters, or B. 17 we did mostly together. That one should be B as well. B. And finally 18, surprise, surprise, bit of a theme here. What capacity, remember, show your work. You should have gotten B for 18. All right, so I hope that makes sense. Come and see me before the test if you're having problems with any of this. But there's the answers to the rest of the questions.
Mr. Maxwell.
Hey.
Said it's all good.